The last type of transformation we have is called a translation. Okay, and one way to think of this is a slide. Like if you have a figure and it just slides from one location to the next, like taking a pencil and just moving it from one location to the next. The shape didn't change, the orientation, the angle didn't change, it didn't rotate, it didn't reflect, but instead it just moved from one location to the next. It just slid. And where you can describe how far it slid to the right, left, to up or down, you can describe that slide, that's a translation. Okay? Once again, notice we start at y, and y is going to slide up to y prime. So that y prime shows me where it ends. So we have the pre-image of y and the image of y prime, which is the new figure. Okay? So when we describe a translation, we're going to tell, well, how far did it shift right to left? Well, to move from y to y prime, y moved 1 to the right, and then 1, 2, 3, 4, 5, 6 up. So you could say it went right 1 and up 6. Okay, so it was a translation, right 1, up 6. Well, we have a way that we write this, and you can see it down here. It's called mapping. Okay, and we started with an x and a y coordinate. So each of these has an x and a y coordinate. Well, when we map it to our new location, moving right 1 adds 1 to our x coordinate. And moving it up 6 adds 6 to our y coordinate. So if I were to look at these coordinates, and my original coordinates for y were 1, 2, 3, 4, 5, negative 5, 1, 2, 3, negative 3. Okay, negative 5, negative 3. Well, to find the new coordinates, I can just plug it into this equation, this mapping. And so I would say my x value, negative 5, plus 1 is negative 4. Negative 3 plus 6 is positive 3. And now my new location, my y prime, using this mapping, is from negative 5, negative 3 to negative 4, positive 3. Okay, so again, in mapping notation, we say xy maps to x plus 1, y plus 6. And that just means it went up 1, that's wrong. It went right 1 and up 6. Right 1 and up 6. Okay? Now, if we move to the next one, again, we have to identify which one is the starting point, which one is the ending point. And we start at h and we move to h prime. So go ahead and think, how would I describe that? Well, everything shifts the same distance. Okay, it's a slide. So it's a translation. And the whole thing slid right 2. And then we can ask ourselves, well, how far did it move up or down? Well, it didn't. And so I'm going to put up 0 here, because that helps us with our mapping notation. So our mapping notation would say, it's a translation on the mapping, xy maps to, and then when we move right 2, our x values change, they go up 2. But our y values don't change at all. I don't go up or down. So y maps to y. It doesn't change. And so again, if I picked an ordered pair, I see j is negative 1, negative 1. So if I take j, negative 1, negative 1, maps to j prime, and so I would say x plus 2, so negative 1 is our x, negative 1 plus 2 is 1. But my y value stays the same, negative 1. And so that shows how we can find an actual point using that mapping notation. Now, going in reverse, what if I give you the mapping and you have to draw the image. Okay? So I would first start with, well, what does this mean? Well, x minus 4, that tells me it's going to move left 4. Left 4. Y plus 0 or minus 0, it means y is not going to change. It's not going to move up or down. So the only thing that happens is it shift left 4. Every point moves 4 to the left. So I find each of those. 1, 2, 3, 4. T prime is 4 to the left. A, 1, 2, 3, 4. A moves 4 to the left. N moves 1, 2, 3, 4. And now I can sketch the image, and we have a translation that shifts left 4. Okay, so hopefully our translations are the easiest here. And lastly, go ahead and pause it. You can try this on your own. But what I would do is I would say, well, this moves right 4. So it's a translation. X plus 4 means I move 4 to the right. And then y minus 7 means I move down 7. So each of our points needs to move right 4 and down 7. So n moves 1, 2, 3, 4, right 4, 1, 2, 3, 4, 5, 6, 7, down 7. And that's n prime. Y moves right 4, 1, 2, 3, 4, down 7. 1, 2, 3, 4, 5, 6, 7. And that's y prime. Make sure as you're labeling, you're putting the tick mark here because it shows us that's our new figure. It maps n to n prime. S moves right 4, 1, 2, 3, 4, down 7. 2, 3, 4, 5, 6, 7. And then D moves right 4, 1, 2, 3, 4, down 7. So now we have our new figure. Okay? And again, it shifts. All of these are shifting the exact same length. It's going right 4 and down 7. And so just a quick overview of our different transformations. First of all, we have reflections, always across a line of reflection. Okay, where that line of reflection is the same distance from the pre-image to the image. So the distance from the line to the pre-image is the same as the distance from the line to the image after the fact. So sometimes we have to find the line, sometimes we have to graph the figure after the reflection. Okay, so we have to understand, and distance to a line is always perpendicular. And so I always have to count perpendicular to my line of reflection. Now with rotations, rotations are going to rotate around a point given a direction and an angle. An angle tells us how far. And so from M to M prime, you have a rotation of 90 degrees counterclockwise. And again, we did that with our patty paper so that we could see it and we could find the ordered pairs of the new image. Okay? And lastly, translation. Another word for translation is slide. And you're just going to take the figure and you're going to shift it from one location to the next. And every point in the original image is going to be shifted the same distance on the x-axis and on the y-axis, same distance, so that we get from our pre-image to our image, remembering that the ones with the primes, S prime, that's the new image, where S is the original.